So today's notes, 1-4-19. Objective, we are going to be setting up and evaluating right triangle trigonometry. Sounds hard, but it's not. Sounds hard. Trigonometry sounds hard, but it's not at all, okay? So first of all, we have to define. Sin stands for sine, and of course, you're going to see it on your calculator as S-I-N, okay? S-I-N, sine. So if you say sin, I'll just kind of chuckle. I'm not really laughing at you. I'm just going to laugh. It's not sin. Sin's for church. It's sine, okay? So the sine function is just a ratio. It's a ratio of the opposite side over the hypotenuse. Okay? So, as an easy illustration, I want you to think about it. Of course, my arm's not working, but just watch the illustration. You're going to do this. As the hypotenuse changes, and as the opposite side changes, doesn't the angle get bigger? Right? Does that make sense? See, if my elbow is the angle, right? If my elbow is the angle. It's just really simple. But as my opposite side is invisible. It's invisible, right? As this ruler gets bigger and bigger and bigger and bigger, and the opposite side gets bigger, the angle changes, right? So there's a relationship between the angle and the opposite side. Now the hard part is we already have a relationship between two triangles, but man, there's like lots of angles. 58 degrees, 21.3 degrees. So your calculator, anybody have a calculator handy? I better grab one. Oh, thank you. So in your calculator, you have all of these functions in your calculator, right? So you've got your sine, your cosine, and your tangent, and in your calculator it can be any angle you want, right? Because as the angle changes, any angle changes, so does the opposite side, right? So there's a different relationship, okay? The calculator has all of those special relationships in them, okay? Now, cosine, or cos, theta, remember theta is the angle, is equal to the adjacent side. Adjacent side over the hypotenuse. Same thing. As the adjacent side gets bigger, or as the hypotenuse gets bigger, it changes the angle, right? And finally, the tangent function, you'll see it in the calculator as tan, but it represents tangent of an angle is equal to the opposite side over the adjacent side. All right, not too bad. So now what I want to do is just set up the trig ratios. Now we're not going to solve any problems until we look at the back side. When we go to the back side, I'm going to show you where trig is actually used, okay? So right off the bat, it says from triangle ABC, write each of the trig ratios from A and B. So let's do A first. Never do the 90. Never ever do the 90. I'll show you an easy reason why, okay? When you are going to use right triangle trig, you're going to shoot an angle and get a height. 90 degrees. You can't get that height, can you? Think about it. If you're sitting directly under it, there's no way you can get a height. You're looking straight up at it. But, so you never use the 90 degree angle, but either A or B. So let's set up A first. So we're going to go first, sine of A. We're going to do cosine of A. And we'll do tangent of A. All right. So, Julia.
You have a pen?
Yeah, you want to borrow my pen? Yeah.
No, I just can't see it.
Oh, sure, Julia. Yeah. Sine A, cosine A, tangent A. How's that? Is that better, Julia?
Yeah.
Okay, so now, let's go walk over to angle A. And let's name our sides. So from angle A, Hannah,
the 4 would be the opposite side. You guys agree with that? You guys agree the 4 would be the opposite? From angle A, you'd throw a rock across to this side. That's my opposite side. The 5 is my hypotenuse because the hypotenuse is always the longest side, or another way is to say it's the one opposite the 90. Does that make sense? And then the 3, the side 3, is next to the angle, so it's the adjacent side, all right? So let's do it. So if the sine, and of course it's up there as well, that handy, big, big letters. If the sine is the opposite over the hypotenuse, it would be the 4 over the 5. It's that easy. There's my ratio. Okay, 4 over 5. Ratio means fraction. So, sine. What about cosine?
3 over 5.
It is 3 over 5 because cosine is the adjacent side over the hypotenuse, right? So the adjacent side, so it's 3 over 5. Nice job, Ava. And then what about the tangent?
4 over 3.
It's that easy. It's that easy. Now, let's go walk over to angle B. So now, Quinn's going to throw rocks at Torin, okay? And I'm pretty sure that has happened before.
Probably.
Probably. So if we go to angle B, things change around, don't they? So if things change around, the 3 now becomes my opposite side, right? Because I'm going to throw the rock across at Quinn. So opposite side, and then the 4 is now the adjacent side. And the 5 is still the hypotenuse. The hypotenuse stays hypotenuse. It's always the longest side. So let's do then and Julia, let me grab a pen. Let's do now the sine of B, the cosine of B, and the tangent of B, okay? All right, well, luckily it's up there, which makes it easy for our notes. Sine of B, here's angle B. It's the opposite over the hypotenuse, right?
Yeah.
So it's just 3 over 5. Cosine of B,
4 over 5.
everybody agree? It's going to be the adjacent over the hypotenuse, which is 4 over 5. Nice job, Ava. And then the tangent of B,
3 over 5.
3 over 4. Okay. Now at this point, show me thumbs up. I want to see if you're here or sideways or down. Because, I mean, at this point, if it's thumbs up, then the rest of this becomes easy. If you get this part right here, the most important thing is knowing what the name of the sides are. Does that make sense? And how do you figure out what the name of the sides are? Not again, seriously. Is you go to the angle. You go to the angle, and then you decide what the names are. Does that make sense? You go to the angle. Okay? Great. Turn the page. It's only this period. It's probably Landon. Hannah, I guess that was you yesterday, huh?
No.
Okay, now, use the tangent.
Speaking of when.
That wasn't you calling me, was it? Okay, so, using the tangent, solve the triangle. So first of all, find the length of BC. So BC is here. Let's call it X. Okay? Okay, so BC, let's call it X. So this is something that builders, contractors, engineers, lots of people do this. You know, for instance, this could be the height of a building or the height of a tree. You shoot an angle. You can measure this distance. What's the height? It's really pretty simple. So first of all, always start with the angle. Okay, so start at the angle. Okay, so we're going to start at the angle. The angle is angle A, right? We know the 36 degrees. Start with the angle. Okay, there's no reason to start with B. We don't know anything about B. That would be silly. Start with the angle. Okay, the angle we know is A. Okay, so we know 36. Okay, now let's name our sides. Let's name the sides. So I'm going to name the sides. Well, the X would be my opposite side. You guys agree with that? It's my opposite side. My hypotenuse is here. And then this side right here, the 12, is my adjacent side. Everybody agree with that? You guys okay with that? Now, here's the thing. I don't care about the hypotenuse in this problem. I don't. I don't need the hypotenuse. I'm not asked about the hypotenuse. So who cares? We don't need the hypotenuse, so bag it. But what we do need to know is the opposite side, and we can use the adjacent to help us. So we're going to use the adjacent side, so we know that, and we want to find the opposite. So, opposite, adjacent. We don't need that. Opposite, adjacent. Which one is it? Which one is it? Opposite, adjacent. It is tangent. You guys see that? You got 3 choices. Which one of the 3 uses the opposite and the adjacent?
Tangent.
You guys agree? Tangent. So let's just write that down real quick. Tangent theta is equal to the opposite over the adjacent, right? Except for I don't want words, I want the numbers. Got it? So, tangent of theta. It is tangent because I want to find the opposite side, and I'm going to use the adjacent side. I don't care about the hypotenuse, so bag it. Okay, now, theta is the angle. So let's put 36 degrees there. Okay, so I'm going to go tangent 36 degrees equals, yep, you're going to need a calculator. The opposite side, what's the opposite side? It's x. That's what we want to find, right? Is equal to x over the adjacent side, which is 12. Okay? Now, if I want to solve for x, I'm just going to multiply up, right? If I have to solve for x, I'm going to times it by 12, times it by 12. So I'm going to multiply up the 12, and I'm going to go 12 times the tangent of 36 is equal to x. Okay, now, just going to use my calculator to do that. So everything is in my calculator. Okay, if you guys can see, I'm going to make sure I'm in degree mode. Yes, I am. I'll talk about that later. So I'm just going to type this in. Just going to type it in just like it says. I'm going to go 12 times tan, my tan button, 36, and I get an answer of 8.7. That's the length of that side. It's about 8.7. So x equals 8.7. Monday, if we don't have a short period, we'll go outside and we'll actually do this, okay? We'll take an angle, we'll measure, we'll shoot it, and we'll figure out how tall the building is, okay? Now, easy, thumbs up, sideways, where you at? Okay, all right. Now let's look at the second example, okay? So, find GP. Okay, GP is right here. Let's call that x, okay? All right, let's go to our angle. What angle are we going to go stand at? Let's go stand right here at the 42 degree. We're going to stand at P, okay? Always pick your angle first. There's no reason to pick angle I. We don't know I. We know nothing about I, so go to the angle we know, right? We don't know. So, but if you go to the angle, then let's label our sides. This is the opposite side. X is the adjacent side. And the IP, or this side here, is the hypotenuse. Again, I don't care about the hypotenuse. I don't need to know the hypotenuse. I'm not asked about the hypotenuse, so who cares? So I don't care about the hypotenuse. It doesn't really matter. Someday, Monday, we're going to ask about the hypotenuse. Today, we don't care about the hypotenuse. Okay? So from the angle, we have the opposite side is 15. We want to find the adjacent. Opposite adjacent. Opposite adjacent. So we look up there. We've got 3 choices. Which one of the 3 uses opposite and adjacent? It's tangent. So today's lesson is always going to be tangent. Okay? We'll mix it up on Monday. Okay? So we're going to set up tangent theta equals my opposite over my adjacent. Okay? Got it? Except for, let's put the numbers in, not theta. Theta represents the angle. So we put 42 there. So I'm going to go tangent 42 equals, let's see, my opposite is 15 over x. Okay, now this is important. You guys see this. Opposite side is on top of the fraction. So the 15 is on top of the fraction. The adjacent is the bottom part of the fraction, so the x goes on the bottom. Does that make sense? You got to put the sides in the right place from the words. Okay. Now to solve for x, I'm going to multiply up the x. Okay. So if I multiply up the x, I will get x times the tangent of 42 equals 15. Now, don't let yourself get confused. Okay. If you want to solve for x, you just divide. Just divide. So if you want, but what am I going to divide by? The tangent of 42. See, that's just a number in my calculator. Tangent of 42 is just a number, okay? So divide by tangent of 42, right? And let's use our calculator. So we're going to go, all right, I'm going to go 15 divided by tangent of 42, and I get an answer of about 16.7. So, moral of the story, listen, I'm going to give you a really nice hint. Watching? You watching? If the x is on the top, you multiply it up, right? Does that make sense? If the unknown's on the top, you just multiply it up and use your calculator. Okay, but if the unknown or the x is on the bottom, you'll eventually have to divide. Now, last problem. So we get a 5-foot boy sights the top of a tree at an angle of elevation of 54. If he is 75 feet from the base of the tree, how tall is the tree? Let's draw a picture. Okay, so I've got a 5-foot boy. And here's my tree. There's my boy. He's going to sight my tree. Now, when I take a look at this, I'm going to draw a right triangle. It's called right triangle trig. But the right triangle is suspended because he's taken it from his eye, and we need to create a right triangle. So the triangle I'm creating is 5 feet above the ground. Does that make sense? So when I get done with this, I'm going to add in the 5 feet. So the triangle I created is actually suspended because of his height. He takes the triangle from his eye. Does that make sense? So automatically it's 5 feet up. So here's my right triangle. Okay? Now, this is a 54-degree angle, right? This is 74, and I want the height of the T. Let's call it tree. T for tree, okay?
T.
All right, so again, go 75, thank you. Thank you. So again, go to the angle first. Always start with your angle. Well, my angle's 54 degrees, right? Always start with your angle, and then label the sides. Well, this would be my opposite side. Does that make sense? Throw the rock across. That's my opposite side. That's my hypotenuse, which I don't care about. And this side has to be my adjacent, okay? So, the two things I want. I know the adjacent. I want to find the opposite. Again, which one of the three is it? Opposite. It's got to be tangent, because I want to find the opposite. I'm going to use my adjacents, these two. So I'm going to set up tangent of theta equals my opposite over my adjacent, right? Let's put the numbers in. Now, this symbol theta means angle. This symbol means angle. Our angle is 54, so we're going to rewrite this as tangent of 54 equals the opposite, which is t. We don't know it. That's what we want to find, is equal to t over my adjacent side, which is 75. Okay, and then to solve for t, I'm going to multiply up to 75. I'm going to go 75 tangent of 54 equals t. And I'm just going to use my calculator. I'm going to just type it in my calculator and go, okay, I can do that. I'm going to go 75 tangent of 54, and I get an answer of 103.2. So t is equal to 103.2, except that's not really true because the tree is suspended. It's actually 5 feet higher, isn't it? If you look at the picture, the tree is actually 103.2, but we got to add in the height of the boy, right? Does that make sense? Because this triangle, this invisible triangle is actually suspended. So we add in the 5 feet. We get 108.2 feet. Okay, that is it. That's right triangle trig. What do you think? It's not that bad, is it? Okay.